and start the recording. What did you guys think of that video? Let me ask it this way. Is it meaningful to have a very narrow field of knowledge that's so narrow it doesn't have anything inside of it? Is that a meaningful thing? Who says no? Sabian, why do you think it's not? Yeah. So that's certainly a great point. You want to make sure that you have stuff that is meaningful to know as opposed to having nothing. And part of the ways we store that, of course, with databases. So like I say, if you're coming in late, I do recommend very strongly that you take notes. Like I said, I'm not requiring it, but I do definitely encourage it. Anything you don't know, because the exam for exam 2 is going to be a very similar format to what you've seen for exam 1. So we'll talk about that a little bit at the end of class. But like I say, organizations have a tremendous amount of data. And, think about if you had no central way to store and manage your data. How would that work out? For an organization of 10 people, could it work out fine? I think you make a pretty good argument that it could. Say your organization has 10,000 people. Would it work out the same for 10,000 people to have absolutely no sort of guidance on how the organization wants to store data? So what organizations do to address this, they use something called data governance. And data governance is going to be the policies and procedures that an organization has in place for how they store, manage, access data. And this is going to have just a tremendous amount of stuff. It's going to have what information is stored, how it is stored, where it is stored. It's going to have who can access what information. It's all covered in data governance. Now, is that going to be handled by one person? Being one person, just kind of organization, 100,000 employees, you think one person controls that? It's usually done by a team. And the data governance team may have people from different functional units. It's not just going to be the database department. It's not just going to be the sales department. It's going to have representation from across the organization. And that's a very important thing when you think about who needs to access what. Would a database administrator necessarily know who needs to have what access and for why they would need said access? They probably would not. So that's why the data governance team is a very important concept as well. So master data is going to be something that we're going to talk about when we're talking about enterprise data warehouses. The data inside of an enterprise data warehouse is the organization's master data. It is data that the organization believes is vital to its survival, and it encompasses basically anything you can imagine an organization would want to know about itself, or not just itself, about the industry they're in, or just any piece of information they find important. It's going to be considered master data. And one component of that is going to be transaction data. So transaction data is going to be any sale of goods or services. It could also, of course, be any procurement of goods or services. So a lot of people think of transactions as being your sales data, but it's really a little bit more than that. Because you think about a transaction, is it not equally important to know what you sold as to know how much it costs you to sell that? I think it's a pretty fair argument to say that those are equal importance. So make sure that you understand what transactional data is. It's not just sales data, although that's a very big part of it. Because pretty much any business we're talking about is going to have some sort of suppliers, and it's going to have some sort of services they're obtaining from external people. Just make sure that you're aware. And what we use databases for is to really make sure we're able to store this in an easily accessible fashion. We don't just want to have the data be sort of on someone's desk on a piece of paper. The way I do attendance, let's use a piece of paper. If I had, let's say, a class of 10,000 people, and I had multiple teaching assistants, do you think I'd use that same piece of paper? Absolutely not. So, it really depends when you're sizing out a database. Make sure that you're considering what you need it to do for the organization. So, in the basic sense, it's going to store those important records. But that's not all it's limited to doing. So, some of the things you definitely want to minimize with a proper database, you want to minimize data redundancy. So, data redundancy meaning we have the same piece of data stored multiple times. So, for example, if you had an address and you had a big transactional table, would you want to manually enter the customer's address every single time they made a sale? No, you'd want to have a customer ID, And from the customer ID, you'd want to be able to pull in their address should you need it, but you don't want to store the same piece of information over and over. That's going to be very costly. A lot of databases in modern time, they're not done on a local infrastructure. They're done on cloud infrastructure. So you're paying for every individual record that you're storing. Now, very small marginal cost, sure, but if you have redundant data, let's say you have the same piece of information repeated 3 times, let's say you have that 5,000 instances of that, it's going to be pretty costly. And not to mention, for things like processing time, it's going to be a lot more efficient to have only one piece of information stored once. Data isolation, it's another thing we want to make sure that we're minimizing. So we're talking about data isolation, we're talking about the data not being shared organization-wide. So think back to a data mart. Is a data mart going to have minimal data isolation, or is it going to have pretty substantial amounts of data isolation? Who can tell me that? So if a data mart is for one functional unit within an organization, by design, it's going to be isolated. There's going to be information silos that are present. Okay, then the last thing we want to minimize is data inconsistency. So data inconsistency can be a pretty substantial problem if you were to sort of, try to find some piece of information and it wasn't stored the way you expected it to be. For example, let's say that you're storing street addresses. And, for some cases, you spell out street. So let's just say 123 Sesame Street. Okay, that's one way to spell that. Okay. But if we're being inconsistent with our data, we may say 123 Sesame Street. Okay? Is that the same address? But it's not consistent. So it's very important that we minimize any inconsistency issues. Now, one way we could do that with an address, very simple. USPS, for United States addresses, of course. They have a big database, and you can use what's called an application programming interface to reference and make sure that you're getting the address that they recognize. So they'll be able to do some sort of a fuzzy match to that text, and they'll be able to sort of make sure whatever you're doing is consistent with them. And if it's consistent with them, are they inconsistent among themselves? No. So, making sure to have minimal data inconsistency is a very important thing. It's not just present in addresses. Let's say people have a name, and let's say someone changes their name. Maybe they get married, maybe they get divorced, maybe they just change their name one day. You want to make sure that wherever you update, that you update it across the organization. Otherwise, you'll have data inconsistency. Does that make sense? Any questions so far? Okay. Now what we want to maximize, first thing is data security. And we're not going to go too much in depth in information security in this class, but just understand that we want to make sure that whatever data we're having saved is protected in meaningful ways. And we're not just protecting it with, one single measure. We're using a layered approach. We're protecting the physical server. What happens if someone walks in and I don't have the door locked and the server that hosts the database is present? Could someone theoretically just walk away with the entire database? Yeah. Even if the database is encrypted and cannot be accessed, it still denies us the access to the database. That could be a problem. Not to mention there's going to be hardware theft. So that's just one example. There's many other examples as well. The main thing is just using role-based access control. So, for example, if I had a student record database, would you want every single person to be able to access every single part of your student record? Okay, some positions, quite frankly, don't need access to certain things. So, for example, I don't need access to your social security number. There's zero reason why anyone who's a faculty would need access to your social security number. But could the financial aid office need access to it? Yeah. Could, let's say, the student billing office need access to it? Absolutely. But I wouldn't ever need access to it. Not anything that I would ever need. So maximize data security. That's very easy to do with various policies and stuff that you'll apply. A little bit beyond the scope of this class, but just understand what's one of the goals of maximizing. Data integrity is another important thing, making sure the data is accurate and reflects the reality. So for example, imagine we have transactional data, and for whatever reason, let's say we had a disgruntled employee. and they slightly change the amount. Maybe they put a random multiplier to change the value by a factor of 1.25. Could they do that? Yes, hypothetically possible. If that happens, we're not maximizing data integrity. So that means that all of our transactions are incorrect. And because it's random, think back to what we talked about in the analytics chapter, where we had both systematic and random error. If it's random error, what do we have to do with it? We got to chunk it. We can't do anything with it. The transaction could be $100, but if it's in the computer as, say, 121.07, it's not the same thing. And let's say we had another transaction that was $50. Okay, and let's say it's in the computer for, let's do 49.07. Okay, completely random. Not off by a lot, but off by enough to make a pretty substantial problem. Because it's random error, we have to just chunk it. So we definitely want to have policies in place to prevent that sort of action from taking place. And lastly, data independence is something we want to maximize. We want to make sure that everything in the database is there for a reason, and the stuff that's in the database is not tied to one specific vendor or one specific application. So early on in the, I don't want to say the term computer age, but early on when firms were beginning to employ technology in their sort of day-to-day operations, it was very common to have an application that basically stored all of the firm's data. And the problem with that is you're tied into one specific vendor. That's something I would recommend very strongly against doing. Because if it's a database, if it's SQL, which we'll be doing in about a week or two, it's certainly something you can take anywhere. It's not tied down to one vendor. Whereas if you have a proprietary way to store your information, it could be tied down to one vendor. What if a vendor raises their prices? What if they go out of business? What if they cut you off one day? Lots of things can happen. You want to be able to keep your data. So starting to keep that in mind. Any questions so far? Like I said, as always, feel free to answer any or ask any questions. I'll answer them, of course. So big data is a very important topic to understand. And as the name would imply, we're talking about data that is large. So you're a small company. Could you have big data? Absolutely. Depending upon your industry you're in, you may end up having big data. But basically, the key here is it's not only large, but it's also unstructured. And there's three primary things we want to know about our big data. We'll know the volume. That's how much size, how large is it? What is the size of the data? So is it, we're talking 1 terabyte? Are we talking 20 terabytes? Or are we talking 50 gigabytes? It's the volume. Velocity, how rapidly is the data being changed? And typically when we say being changed in the context of big data, I don't mean existing records are being manipulated. I mean how often are things being added to. So, for example, if we're having transactional data, which isn't really a great example because it's very structured, but let's just say we had transactions taking place that were not structured and just taking place over and over and over, the velocity is going to be how rapidly are we adding new transactions. Okay, and then lastly, variety is dealing with how unstructured is it. In other words, if I have a database of nothing but pictures, so I have a large image database. Maybe we have not just an image database, so we have a large surveillance video database. It's going to be pretty unstructured, but the variety is going to be pretty low because when we're talking about the context of it, it's going to be the same format for everything, or at least a similar format for everything. Now imagine I just had a very large data set that had images, videos, audio, all sorts of files, maybe even some text thrown in there. It's going to have much more variety. Does that make sense? So there's the 3 V's, and they're very important to understand in the context of big data. Okay, so some examples of it. Traditional enterprise data, probably not the greatest example, although even any enterprise certainly could generate unstructured data. So it's certainly going to be something we could see. Machine-generated sensor data. This is going to be data that's going to be somewhat structured. However, it's going to have a very large velocity associated with it. Because if you have, let's say, one sensor, let's just say it is like a sensor in an aircraft engine. Okay. That one sensor could potentially give us multiple observations per second. And do you think an aircraft only has a single sensor? I'm no aviation expert, but I guarantee you there's more than one sensor. So that's certainly something we could see. And also in manufacturing, it's very common to have various sensors that are providing real-time information, and we want to have a way to store that in case we ever need to reference it. Also, if we want to do something like promote the Kaizen process, continual improvement, that's certainly something we want to see happen. Social data. Social networks, of course, are a great way to have unstructured and large amounts of data. So imagine we have a Twitter account as a company, and we make a new product. And we want to gather all the data and see what people are saying about said product. So that's going to be an example of big data. They could have pictures of the product. They could have text talking about the product. They could have a video of them talking about the product. Just a tremendous amount of ways that they could discuss a product. That's just one example, of course. That's basically what we're going to talk about with big data. Just make sure you kind of understand what it is. There's several issues to be aware of, and I'll kind of go over how you may choose to mitigate them. The first is that you can get big data from pretty much anywhere. A sensor could generate it. You could get it from a social platform. Let's say you get it from a social platform. Do you inherently trust all of the people who are posting? In other words, is one post equal to one user's opinion? Who says it is? Who says it's not? So, Boone, why do you think it's not equal to one person's opinion? Okay. Are all social media accounts real? Let me ask that. There's a lot of bots. So imagine, and I'm not saying this happens, but I'm not saying it doesn't happen either. I certainly wouldn't rule it out as a possibility. Imagine you come out with a new product, and you have a competitor, and your competitor is unable to catch up. So what they could do is they could post a lot of fake information on social media regarding your product. Is that an ethical thing to do? I'm not here to tell you if that's ethical or not. That's for you to determine for yourself. I never try to tell people what to believe or anything like that. Just make sure that you understand that big data is not necessarily coming from a trusted, reliable source. It can be, but you don't want to assume that. Dirty data. So dirty, of course, in this context, is referring to sort of the structure of the data. And inherently, by definition, it's unstructured data, you know the data that you're dealing with is going to be difficult to work with. So if you're doing text data, you can do some various text mining techniques. Stuff that's a little bit beyond the scope of this class, but just understand there's certainly ways to work with unstructured data. It's not as easy as working with structured data. Stuff we've done up to this point in Excel. Is it pretty easy to take the sum of 10,000 transactions? That's pretty easy. Is it pretty easy to take the average of 20,000 transactions? Yeah, it's all easy. Imagine if I gave it to you in an unstructured fashion. Then would it be so easy? No, it wouldn't. And then, of course, rapid change, having a very large velocity. How do you work with something that is giving you data in real time that you're wanting to get sort of a snapshot of? Well, there's a lot of different techniques to do so. Of course, the most basic one would just be to, basically take some subset of that data and then work with what you have, and then, sort of build assumptions based off of that. There's some downsides to that. What if it's not representative? What if you called it at a bad time? Lots of stuff could go wrong with big data. Okay? But it's useful. Okay? So imagine you wanted to do experimentation, and you wanted to roll out a new website. So you have, tens of millions of visitors a day to your website, doing really well, but you're noticing that people aren't staying on your website for very long. So what you could do is you could run 2 different versions of the website and see which one people stay on more. Very basic example. Micro-segmentation of customers. We've talked about this a little bit in here up to this point, where, traditionally, businesses had these sort of generic segments that apply. And I think I used the example in here that, I would probably be classified as a pretty similar demographic to most people in here. Young, millennial, whatever you want to call it. It's going to be a general segment. But do you think that I would probably be the same type of customer as most of you? Probably not. I'm at a very different spot in life than most people, and that's fine. But, if you're a company, would you target me the same way you may target a college student? No, you probably would not. So microsegmentation is targeting the individual. And we do that through obtaining data from data brokers, or if we're smart, we can even obtain the data ourselves and save a pretty substantial amount of money. There's different ways to do that. You can certainly do that via social media. You can have people fill out a survey. All that's to kind of determine what they want to, what type of customer they are. That's at a very individual level. Is that creepy? You may think it's creepy. Is that cool? You may think it's cool. There's lots of different ways you can view that. I'm not here to tell you whether this is a good or a bad thing, but that's what it is. Make up your own mind if it's good or bad. So also creating new business models, making sure that we're having a sustainable business model that passes simulations and is likely to have a positive, customers are likely to view it positively. So that's pretty basic there. Product development, pretty straightforward. Test out your products, do various stress tests on them. Like for example, if you're coming out with a new laptop, what's a stress test you may do? You may open and close the lid 100,000 times and see what percentage of them break. That's a very common type of test for that sort of thing. And obviously, you'd have different sensors on that machine that would sort of tell you where the stress is occurring. You could also sort of measure the heat. Various basic things you can do there. Okay, we've talked about data warehouse is going to be where we're storing all of the data that's relevant to our organization. Of course, the data mart is going to be some scaled down version of it. It's going to have some components, but not 100% of it. It's going to be geared toward a single functional unit. Of course, if we're talking about functional unit, it's going to be another term for department, a little bit different, but just understand we're talking about a department. Okay, and with a data warehouse, it's important to understand that it's not just going to be some entirely large thing that's completely unstructured. It's very structured. It's going to be organized by different subjects. A lot of times that'll be in tables. So think about a big database. You're not going to have every single field inside of a single table. It's going to be very integrated into whatever products or services you're using. I should say whatever software you're using. So for example, if you're using an ERP, you're probably going to have access to both enter and sort of not remove data, but sort of view data and make various conclusions within the ERP. It's going to be time variant. Most of the fields in here are going to have a time variable associated with them, so you can tell when something occurred, when it was added, all that sort of stuff. It's going to be non-volatile. That's a very important thing. If it were volatile, that means anyone could go in and change it at any time. With a data warehouse, that is a very bad idea. You want to have very few people who are able to directly edit existing records. Why might that be? Why can't anyone just go in and edit whatever record they want? Who thinks that's a bad idea? Why is it a bad idea? They can make mistakes. They can make mistakes on purpose, like a sabotage, corporate espionage. There's lots of different things that could happen. And you want to avoid all those, so make it non-volatile. Multidimensional, pretty self-explanatory. You have different fields within inside the tables. Don't need to talk about too much about that. I'm just going to briefly pause the recording here. Give me just a second. All right, who wants to share an opinion about that? No wrong answers. Who has an opinion about that video? Did you like it? What'd you guys think? Savian. Yeah, so I don't know how much you guys know about the Dilbert series, but of course Dilbert was the guy who gave the thimble of knowledge to his boss, and I think his boss's name was like Pointy Hair, something goofy like that. Anyway, not important. But what is important is that a good thing to do? I would make an argument that in most cases, technical knowledge is even less relevant than your social capital and your social awareness, especially in a business setting. There used to be a sign hanging at a place I worked that said, people won't remember what you said, but they'll remember how you made them feel. So that's a very important thing, is to make sure that people like you. You don't want to be rude, especially not to your boss. Because what can your boss do to you? They can terminate you. Not only can they terminate you, that not only loses your current employment, but can that also affect your future employability? Absolutely. If I were a boss and I called up a previous boss and I asked the question, is this employee eligible for rehire? And the answer was no. Do you think I'm likely to hire that person? Probably not. But if the answer was yes, and they were willing to go into a little bit more detail, which, by the way, personal aside, I would never recommend giving more detail than is absolutely needed, because that opens you up for potential liability. So if someone calls you, let's say you're a manager, I don't know, 10, 15 years from now, and someone calls you about a former employee you had, I would strongly recommend against giving any specific information. I would only answer the question, are they eligible for rehire, personally. And I would also confirm the age that they worked there, or the time period that they worked there, rather. Because if you don't, let's say you say an information, you could be held liable. People have gotten sued over that sort of stuff. Not a risk I would personally be willing to take. Having said that, you can certainly have the former employee write you a waiver of liability, but that's getting pretty complicated, and getting lawyers involved and stuff, and it's not always going to be enforceable anyway. So something I would recommend against. Does that make sense? Okay. Hopefully you already knew that. So knowledge management. We talked about all the different pieces of knowledge that an organization may have. They're going to have just a tremendous amount. You have an organization with 10, 20 functional units. Each of those functional units are going to have some information that's relevant to them, to how they do their jobs. That's going to be intellectual capital. And you think about tangible versus intangible assets, I would make an argument that physical assets, of course, are going to be one thing, but intellectual capital is kind of an interesting thing, because if it's in a form of a patent or a form of a copyright or some sort of intellectual property, it's both physical and intangible. So it's very difficult to sort of do it. That's not true from an accounting standpoint, but from a finance standpoint, sort of thinking about things from that perspective, that's how we're going to see it. So you have explicit knowledge. That's going to be knowledge that can be easily recorded. So if I had a knowledge management system that had a tremendous amount of knowledge stored within it, everything that's within that is going to be explicit. It's stuff that you can, in fact, record. You can share. Tacit knowledge is going to be a lot different. Tacit knowledge refers to, I don't want to say like experiences, but think about a gut feeling. A gut feeling is a very tacit thing. Can you describe a gut feeling? Can you describe why someone at night scares you if you're walking down the road? No, but you have a tacit knowledge that you should probably go on the other side, maybe pick up the pace a little bit, whatever you may do. It's tacit knowledge. You can't explicitly describe it, but it's something you gain from experience. And that's basically what we want to talk about there. And we have the knowledge management life cycle. I'm not going to directly have an exam question that relates to this, but definitely make sure you understand at the basic level. We acquire knowledge. We apply it to various business problems. We assess whether or not that worked well. If it didn't work well, we would go back to acquire. If it did work well, we'd continue on to create. So we're actually going to sort of formally record the information, identify, sort of determine what knowledge is valuable, what's not valuable. Then you sort of refine it. And once you've sort of gathered that on an individual level, that's when you begin to disseminate it. And basically, you have internal organizational knowledge as well as external knowledge. So if it's internal, you're going to share it on internal platforms. External, maybe you share it on external platforms. Maybe you rely upon existing external platforms. That's basically what the whole process boils down to, though. Not very complicated or anything. So we're going to talk about relational databases. And this is where it becomes really vital that you take notes, because up to this point it's been pretty theoretical. This is where we really begin to apply, and this is where we'll spend the next couple of class days, is on the entity relationship diagram. So back up a little bit though, we have a database management system. That's going to be a piece of software that allows users to easily interact with the database. Maybe they add records with it via form. Maybe they receive reports about data that's existing in it. Lots of different things we can do. But in general, in this class, we're going to be using just raw SQL. I think it's important to understand the inner workings of a database, particularly when you go out into the private industry. I think that's something you'll definitely come across at some point in your career. So we're going to talk about the modeling for that. It's going to be done by entity relationship diagram. So I'm going to go over these different parts. Like I say, feel free to tell me to slow down. Feel free to ask me to repeat something. I'm always happy to do so. So I have an entity. And the entity is going to be the noun that represents what we're storing information about. So if you think about a database, it's going to be the table. Each table is literally an entity. So on the entity relationship diagram, it's called an entity. In the actual database, it's called a table. Does that make sense so far? Okay. Then we have instances. Okay, an instance is going to be an occurrence of that entity. So if I had an entity for student, okay, what would an instance be? It'd be a specific student. Another way to think about that in terms of a database itself, it's going to be your records. It's going to be your rows, okay? And then attributes describe the entity. So if I had a student entity, I may have an attribute for first name, an attribute for last name, an attribute for address, an attribute for student ID number. Does that make sense? It describes the entity. Now, in a database, that's going to be referred to as a column. So you have a table, and the table is going to have some number of columns. Each of those columns are going to be a variable. It's going to be an attribute. So in the context of an ERD, entity, instance, attribute. In the context of a database, table, record or row, and column. Everyone with me so far? Okay. We have a primary key. A primary key is going to be an attribute that uniquely identifies each instance of the entity. So, for example, if we have a student entity, would first name be an example of a primary key? Could it? Unless you have a very small school, it's not going to be a great example of first name. It's not a unique way to distinguish each and every record. What about student ID? Could that be a primary key? It should be able to. And then, of course, a foreign key, so it gets a little bit complicated. Foreign key is going to be a primary key in another table. So the table that it's in, it is not acting as a primary key. But it is, in fact, a primary key in a different table. Does that make sense? So imagine if we had a student table, we identified each of those instances with a student ID. Student ID with the primary key in the student table. But if we have student ID in another table where it is not acting as the primary key, it's going to be a foreign key. Does that make sense? Okay. So any questions about this? Everyone got good notes on it? If you didn't know it already, of course. All right. So now we're going to talk a little bit about relationships. So in this context, obviously we're talking about relationships between one table to another, one entity to another. It's called entity relationship diagram. So what this is really saying is we can have 0, it's going to be the minimum amount, or you can have the maximum amount. So this first bit right here, that is the minimum. The second bit is the maximum. So if something is 0 to 1, it means it's not required, but it can only occur once. So a specific instance will only occur once. If something is 0 to many, it means it's not required, and there's no maximum amount that it can occur. If something is 1 and only 1, it means there will be 1 and only 1 instance of that relationship occurring. 1 to many means there's a minimum of 1 instance of occurring, a maximum of infinite. N to many, n is going to be some integer, and it's going to be represented as the minimum number of instances that the relationship may occur. It's very rare to see that one. Typically speaking, you're either going to have a 0 or a 1, but you could see an n. And then many to many is something we're going to talk about next class. I don't want to go too far ahead of myself. Basically, it's where you have no minimum or no maximum. And you really shouldn't have that one. We'll talk about how to address it next class. So that's pretty much the basics of an ERD. That's what they look like. We'll cover this in a lot more detail next couple classes. We'll do some examples together and make sure everyone's in a good spot with it. Just kind of wrap up today. We talked about managing data, talked about databases, talked about entity relationship diagrams some, talked about data warehouse and data marts, as well as knowledge management. Now, we're not going to wrap up quite yet. There's a big elephant in the room I probably need to address at some point, so now's as good a time as any. The exams. I was a little bit disappointed in a lot of the exam grades. They were lower than I would have liked to have seen. So what I'm going to do is I'm going to have a volunteer pass out a little survey. It's optional to fill it out, but I'd encourage you to do so. I'd encourage you to give me feedback, let me know what I could do better. So, it's got some questions on here. Like I say, I'm not trying to figure out who wrote what. So like I said, I'm going to leave before these are passed out, or I guess before they're handed back in to me. Do I have a volunteer who's be willing to pass these out for me and take them up and take them over to my office or the lab in 050? Appreciate it, Savian. And if there's any extras, you'll give those back to me as well. Like I said, I'm going to get out of here. I encourage you to fill it out. Yeah, like I said, I hope you all have a great day.